Good evening, good evening, good evening, my 12th standard warriors. Welcome to the next session of alternating current in the Pathfinder series with me, Shreyas, your physics master teacher at Vedantu. Hello, Selva Kumar. Hello, Ankit. Welcome aboard. I am Shreyas. I am your physics master teacher, and I have been teaching kids for a very long time now. And I am here on YouTube so that you can learn physics the fun way, you learn the concepts the right way, and you learn to apply these concepts for solving the physics problems. So welcome aboard and happy Engineers Day to all of you. Oh, thank you, Ankit, for wishing me happy Engineers Day. And I hope you make us all really proud by becoming really great and really marvelous engineers. I hope you create some nice inventions. I hope you create some really cool things in your future life. And you remember this channel, as probably a stepping stone in your career and your education. So welcome aboard. And before we begin, just do us a small favor by smashing the like button down there, and also check out our Telegram channel in case you want to check out all the important updates, the the PDFs as well as the timetable. And if you want to join my batch is going to start this Monday. I just conducted a session just some time back on the batches which are starting on the Vedantu Pro subscription. But before that, have a quick look at the timetable. You can probably take a screenshot. It is also going to be uploaded on our Telegram channel. So a lot of lectures for you. JEE 2022. This was the first class. Today is the second class. Another class on Friday. And more classes will also come up. So guys, please do join the Telegram link as well. Thank you, Neha, for all the love from Kerala Bacha. Hi, Teresa. Hi, Surya. Hello, Hari. Welcome. Good evening. Good evening. Good evening. And guys, I'm really hoping that you will be there on Monday in the Vedantu Pro, because a new class, a new batch is starting. Wasim sir, Shimon sir, and me. All of us are starting problem solving courses. I've conducted a beautiful class just some time back. Just check it out. All the details are there in the 25-minute video. And probably this day is probably very good, lucky or what, because apart from the results that we just produced in CBSE, ICSE boards and JEE mains, today the final results for JEE mains were also announced, and Vedantu students have scored really well, I must say. The results are still coming in, but till now I have got a number, and that says that All India rank 35 is from Vedantu, and I am really proud to tell you all of this. Hello Harris, hello Sadvika, hello Om Ganpure, welcome aboard. Hello Aman, good evening. Hello Nikhil, hello Ahari. Yes, the concepts that I teach in YouTube for JEE is enough, and you should follow it regularly. That's very important. You should not just see a lecture and then miss few classes, then probably will miss it. So watch all the kinds of classes, whatever we conduct. See, we'll first build up the basic concept, then I'll conduct advanced classes, then we'll conduct some Menti quizzes, then we'll conduct some problem solving sessions, we'll conduct revision sessions. So you should attend all these sessions. Only when you are regular, only then you can, improve. And then if you want more support, more help and a more systematic approach, then check out our pro subscription classes. My batch is starting this Monday, and remember, you have all the three options. Whether you want doubt, then you go for the classic. If you want plus, then if you want personal mentorship, you go for the plus version. The classes are priced at around 3,000 rupees per month, which is very affordable. And do not forget to use my coupon code SHHPRO. Only then you will get the discount of 10%. Which reference we can follow, says Sadvika. Thank you, Raji Pratap, for loving me a lot, and love you too, bacha. So you should follow books like H.C. Verma, then you have your NCRT, and then previous year questions, DC Pandey, Tattva module. These are good books. Okay, hello Ahari. Can we join for 1 month? Yes, Ahari, definitely you can join for 1 month. And in this 1 month, you will see a lot of courses, KVPY, my micro courses, the long-term batches. All of this will be available to you. You can experience the entire thing. If you don't like it, it's okay. Don't buy it next month. It's okay. Watch my lectures on YouTube. No problem. Oh, yeah, I can see that, Surya. A lot of colleges have started, and I can see, the attendance also is getting affected, especially in the live classes, because a lot of the colleges have started and many students are now trapped between maybe your coaching or maybe your school homework or even just your school, probably attendance. That's affecting your studies. But guys, Please stay focused. Do not forget your JEE studies. That's very important. Please get your friends, remind them, give them a smack on their back and like, hey, come on, please study for JEE. Don't get rid of JEE studies. So let's start with our class. And today we are going to see AC with resistance, with capacitance and with inductance. If you recollect, before this we have studied just when voltage passes through a resistance, when a current passes through a resistance, then a potential difference is created. V is IR. Similarly, we have seen capacitance connected to a battery and we see the capacitor gets charged. Inductor connected to a battery, you see the inductor starts acquiring that current and the current grows in the circuit. We have also seen LR circuits connected to a DC source. This lecture is different because these components like resistance, capacitance and inductance, they are now going to be connected to AC. So the voltages will keep varying, currents will keep varying. So the behavior is slightly different and that's what we have to see. Hello Rihan Kota, welcome aboard. Yes. Yeah, I know you guys have a lot of homeworks, but it's okay. You have to stay focused. Everybody has the same pain points. You cannot sideline JEE studies. You have to find time and manage time somehow. Now let's see what happens when you apply some AC voltage across the resistance. There will be some voltage drop. There will be some current flowing through it. Let's say the current will also be an AC current, and because of that I will say the current is I naught sine omega t. Fair enough, the current will be I naught sine omega t. Now what will be the voltage drop across the resistor? That I can use Ohm's law. So by Ohm's law I can say, the voltage across the resistor is I into R. So this will be nothing but I naught sine omega t into R. So R I can bring it together. So I can write it as I naught into R into sine omega t. Now this voltage across the resistor, I can also write it as VR naught. This is a constant. I naught is the current amplitude, R is the resistance. So I can rewrite it as a constant into sine omega t. So what I have done over here is that maximum voltage is maximum current into R. So please remember, these both are amplitude of voltage and this is nothing but amplitude of current, and this R is obviously just the resistance. As simple as that. Now what did we see from these equations? Observe it carefully. If you notice, there is one interesting thing. If current is a sine function, voltage also came out to be a sine function. That means if somebody draws the graph of current, if this is the graph of current, the voltage graph will also be like this but with a different amplitude, because the amplitude of voltage is VR naught, the amplitude of current is I naught. What does this tell you? Both the voltage and current are in the same what? Remember waves, remember SHM, if graphic periodic functions, if two graphs go up and down simultaneously, then what do you say? Ahari, even if you're a NEET student, when you buy the pro subscription, you automatically get enrolled in my courses as well. You can search it. Just check the video which I uploaded, Ahari, just some time back. Okay, in that I have mentioned how to search for my micro courses. Just see that, you will get to know. Okay, even if you are a NEET student. Yes, they are in the same phase. Correcto. And last lecture we have studied phasor diagram. So whenever you have periodic function, you can think of a circular motion which keeps rotating with constant speed, and the corresponding shadows or projections give the values of the voltage or the current or that parameter which is varying. So think of a phasor diagram and then you can think, yes, the voltage as well as the current both will move together with the same angular speed. Their lengths will be different, Their lengths will be different, that's okay, but both of them will be together. The phase difference between them will be 0 degrees. Is everybody clear about this? Why the amplitude is not same, Sudarshan? Because of this R. You can see I naught into R is VR naught. So amplitude of current into resistance. So if resistance is not 1, then voltage will also not be the same as the current amplitude. Second thing, current is measured in amperes, voltage is measured in volts. So you cannot compare voltage and current. Is current more or voltage more? You cannot compare. They both have to be of the same units. Okay, I hope this is clear. Ankit, remember the angle between the voltage phasor and the current phasor is called as the phase difference between voltage and current. So hence here current and voltage both go up and down simultaneously. So both are rotating together. So hence the angle between them is 0 degrees. I hope now it is clear. Thank you, Om Ganapure. Alright. Yes, Rajay Pratap, when you join my course, I will also give the link of the private Telegram group of mine where all the like-minded students will be there, and you will get those special assignments of my micro course only on the Telegram channel. All right, apart from the micro course that you are attending, so you will be getting all those PDFs of the questions on the Telegram channel. So that's very, very important. All right, I hope now it is clear. Very good, Nikhil. Now Ankit also understood. Theresa V. Barton also understood. Vikram also is on fire. So what is the conclusion? The conclusion is this: if current is I naught sine omega t, EMF or the voltage across it is also E naught sine omega t. Both are sines, or sine functions. So both of them will go up and down together. So there is no difference in the phase. If you remember wave theory, which you have studied in light or sound or transverse wave, there is no phase difference. So in the phasor diagram, both voltage and current will move together. For those of you who have forgotten phasor diagram, let me remind you. So if you have if you have an arrow like this which rotates like this, okay, and let's say you have a graph over here. Right now you can see the height is this much. So on this graph you will probably see the value over here. So this is the value. So this is the shadow. Now as and when this arrow mark rotates, okay, you will see the length of this height or the projection or the shadow, it will increase. So this value will also go up. So as this arrow rotates, this point over here will also go like this, and it will go up and down as it rotates. So this is called as the phasor. This is the time graph, voltage versus time, current versus time. This is the phase. The height is the radius of this circular motion, if you remember it correctly. All right. Yes. Now let's move on to inductor. So similarly, if you have an inductor, how do things vary? Well, I have a voltage which is AC, okay, it might be V naught sine omega t, or I can take it something else. Let's just forget this for now, okay. Let's say this is not V naught sine omega t, this is some voltage. There is some current flowing through it, and let's say I assume the current to be I naught sine omega t, okay. Current is I naught sine omega t passing through the inductor. I want to find out what is the voltage. I want to figure out what is the voltage across it. Let's see how to do that. We all know that the voltage across the inductor magnitude wise is nothing but L di by dt. Remember, forget the minus sign. I'm just interested in the magnitude of the voltage. Karan, I'm very good bacha. Alright, chalo. So Rajay Pratap, I would love to create my own account bacha, but the problem is the spamming. So I would be probably not in a position to reply to all the messages. So that's why I don't have my own personal account shared. So if anything happens, you can always leave a comment after the YouTube video ends. I definitely will respond to all your comments which you post on YouTube. Okay? Chalo. Karan, my name is Shreyas Bacha. Okay? Cool, it's there. My Instagram handle, that's there. All right. So when I use this, what will happen? L, derivative of current. What is the current? It is I naught sine, it's given. I have assumed it, omega t. So L will come as it is. I naught is a constant as it is. Derivative of sine is cos omega t, but this omega is getting multiplied by time, so omega will also come outside. So this is what I will get. Everybody clear till this point? Everybody fine till this point? Just look at this. That's what I'll get. Now comes the tricky part. So what I'm going to do is I'm going to write this as voltage across the inductor will be I naught into omega L into, instead of cos, what I'll write it as sine of omega t plus pi by 2, which is 90 degrees. Sine of theta plus 90 will be cos, yeah, second quadrant. Now observe carefully and look at this. If current is sine omega t, voltage is sine omega t plus pi by 2. What does this mean? It means if I have a graph and if I show the current as a sine function, if this is the current, this is cos function, and we all know cos function starts from the top. We all know this is nothing but the voltage. It's a cos function. This is very interesting. Okay, so this is how it looks like. So there is clearly a phase difference over here. Guys, can you see that? Can you see that there is clearly a phase difference over here? Manikanta Lakulia, I have already created playlists for all the chapters. Just go to playlist tab. All playlists are there. I hope you will be able to find it. It's very easy. So you can see voltage and current are not in phase. So if at all one were to draw the current phasor, if this was the phasor of the current, how should I draw the phasor of the voltage? Voltage is pi by 2, 90 degrees ahead of omega t. It's already plus 90. So if current is sine omega t, voltage is sine omega t plus pi by 2. That means I should show the voltage phasor already ahead by 90 degrees. So this is the voltage phasor. Now does it make sense? Okay. So pi by 2 minus theta. So that will be also correct, but you are getting minus theta. I don't want minus theta. I want plus theta. So because I want plus omega t. So to compare, I should have omega t and omega t. I don't want pi by 2 minus omega t, because minus omega t is opposite in direction. So I don't want that. So to keep it positive, I have made it look like this. I hope that makes things clear. All right. Now, once you get this, here is one small change I will do. I will write this as, okay, I'll write this as I naught, okay, into, or basically all these things, I naught into omega L as V naught. So the induced voltage has now become V naught sine omega t plus pi by 2. Now if you compare this, you will clearly see V naught is I naught into omega L. Now try to recollect how was voltage related to current in terms of Ohm's law. So voltage was current into resistance. Now here also you are getting a very similar term. Voltage is current into omega L. So what should this term be? Think about it. What should this term be? It is very similar to resistance, but it is not resistance. It's doing the job like a resistor, like it is opposing the current. If this term is more, then the current will be less for the same voltage. If this term inside the box is less, current will be more, okay, for the same voltage. So it opposes the current. But there is no loss in terms of heat in an inductor. We all know inside an inductor energy gets stored in the magnetic field, and magnetic field stores that energy faithfully. Half Li square, if you remember correctly, that was the energy stored inside the inductor. So when the inductor gets discharged, it gives back all that energy in the electrical form. That means the energy is not lost. Whereas in case of a resistor, the energy is lost. So we need to define a new term. That term is called as reactance. Reactance is having similar job like a resistor, as in it opposes the current. More the reactance, less is the flow of the current. But unlike resistor, there is no loss of heat. That's why a new name has been given. So I'm going to call this as, because this is inductor, so I'm going to call it as inductive reactance. Inductive reactance, the unit is still in ohm, obviously, because V is IR, so obviously the dimensions of this, the units of this should be as that of the resistance, which is ohm. The symbol for that, very, very important, look at it. So the symbol for that is X. So reactance is measured in X, but because it is inductive, I'll put L as a subscript. So XL is nothing but omega L. So this is something which you should know, and therefore I will get V naught is I into XL. So that's also something which you should know. Voltage is current into resistance, but this resistance is reactance. Voltage is current into inductive reactance. Inductive reactance is omega L. Keep this in mind. Everybody clear about this? Understood it now? So, does this resistance cause heat? No. Does this resistance oppose the current? Yes. That's why I don't call it resistance, but I call it reactance. Unit ohm. As simple as that. The symbol for that is X. Subscript L stands for inductive, because it is because of an inductor. Keep this in mind. Let's move ahead. Very good, Anna S. Matthew. Now, that's what is there on the next slide. You can see the voltage is a cosine graph, current is a sine graph. There is a phase difference. They are not together. Phase difference of pi by 2 or 90 degrees. So, here the voltage is ahead of the current. Okay, the voltage is ahead of the current for an inductor. Okay, the EMF leads means ahead. It's ahead of the current because both of them go anti-clockwise. So voltage is ahead of the current by 90 degrees. The reactance is omega L. Omega is frequency angular wise. So it is 2 pi f, where f is the frequency. You don't have to remember this, but this is just given just for your information. Alright, so this is something which you should know. Very important, all these things are given. Now the same thing is also true for capacitance, but there is only a small change. So guys, if somebody were to assume that the current was I naught sine omega t, okay, the current in this circuit is I naught sine omega t. Remember, this voltage is connected to this capacitor, and if you try to find the voltage, remember voltage is Q by C because Q is CV. And what is Q? Q is integral I dt. So when you integrate and find this out, it comes out to be I naught, okay, and you will have C omega. The omega comes below because during integration, that term which gets multiplied with the variable comes below. I hope you remember, when you take derivative, it comes just outside as it is, but when you take integration, it comes below, divided by, okay, so that's what happens. And this becomes cos omega t again. But there is a minus sign which comes with, okay, so there will be a minus sign out here, and what happens is it looks like this, sine of omega t, okay, and this will be minus pi by 2. That's the only change which comes out. So there is a change over here, and you will see omega t minus pi by 2. That's what comes out over here. Now once you get this expression, don't worry about this derivation. So it's very similar to the previous one, except for derivatives you have integration and all of that. Now what happens over here is that, guys, observe this. This term is constant because C is constant, omega is constant, I naught is constant. So I can write this as V is equal to V naught sine omega t minus pi by 2. Now what is V naught? So therefore V naught is I naught into 1 by omega c. Interesting, interesting. Observe this carefully. V is I into 1 by omega c. If you compare it with voltage is current into resistance, you will understand this is similar to resistance in capacitor. But the only difference is now this will be called as capacitive reactance. Capacitive reactance, again it will be expressed in ohms because this is because of a capacitor. It's like a resistor. If this whole quantity increases, current reduces. It opposes the current. If this increases, this reduces. That's what it is. Therefore, I will write this as V naught is equal to I naught into XC. This XC is 1 by omega C. Keep this in mind. This is capacitive reactance, XC. XL is inductive reactance. Inductive reactance had omega L. Omega L was in the numerator. For capacitor, it is 1 by omega C. That's what you need to keep in mind. Again, you can see voltage is current into resistance. Instead of resistance, you have reactance. Now, also remember one more thing. If I draw a graph, let's say for example, this is the current. Okay, this is the current graph. Because you can see over here, okay, the voltage graph is having minus pi by 2. Things will change. Yes, you will see the voltage graph will start like this. Yep, it will start like this. Yep, it will start like this. This will be the voltage graph across the, capacitor. So that means in the phasor diagram, if the current was here and it is rotating with angular speed omega, this is the phasor of the current. If it rotates like this, obviously voltage will also rotate like that, but it will be behind because of this minus pi by 2. So you are going to see the voltage phasor right over here, and this will be 90 degrees. It will be behind. That's the only change. Yes, the current will lead the voltage by 90 degrees. That's something which you should keep in mind. Yep. Is that clear? So very, very important slide again. So current is ahead of voltage. Okay, very simple. So I'll show you the slide over here. So if voltage is some sine function, okay, current will be something else. Oh, by the way, in the previous slide I had shown current as I naught sine omega t. So EMF will be sine omega t minus pi by 2. Don't get confused. You'll be like, sir, in the last slide you just showed minus. It's one and the same thing, guys. If you write current as I naught sine omega t, then voltage I have to put it behind, okay, by minus pi by 2. If I write voltage as sine omega t, then obviously current will come ahead of the voltage by plus pi by 2. It's one and the same thing. Current leads the voltage by 90 degrees. XC, oops, there is a mistake out here. I need to correct it. This is 1 by omega C. Yeah, this is 1 by omega C. Okay, so that's something which you should know. Yeah. How will capacitor store energy? Very important question, Sahasya. Capacitor also stores energy in the electric field between the plates. So the energy is not lost technically. Energy is still stored in between the plates of the capacitor. So that's why I do not call it as resistance, because in resistance it is lost in the form of heat. Okay, chalo. Let's get moving to some questions coming up on your screen, and here it is. The first question. Let's see, guys. An inductance of 1 Henry is connected in series with AC source of 200 volts and 50 hertz. What is the inductive reactance in ohms? Come on, straightforward question. Let's see how many of you can do this. Berlin, Raishram, definitely bacha, you can definitely watch this lecture for NEET. Okay, very good. Let's see whether the answer is actually C. Yup, it is C, guys. Very good. Amazing go. So what you need to do is inductive reactance. That means XL. XL is omega L. That's how you need to remember it. And what is omega? Omega is 2 pi F into L. So 2 pi into frequency. Frequency is 50 hertz. What is L? L is 1 Henry. So this will become 50 into 2, which is 100 pi. But this will be in ohms. As simple as that. Correcto. That's it. That's the answer. Excelente. Let's move on to the next question. Okay, here it comes. A capacitor of some capacitance. A capacitor of some capacitance has reactance X. If capacitance and the frequency both become double, then the new reactance will become how many times of the previous capacitive reactance? Come on, my warriors. Come on, my warriors. Let's see how many of you can do this. A capacitor of some capacitance has some reactance X. So if you double both the frequency as well as the capacitance, let's see. Hello, Dark Knight. Welcome aboard. Come on, bacha log. Think. Dark Knight saying A, Nikhil saying C. Okay, there is a conflict. People are getting confused. What should be the correct answer? Come on. Akash, you can leave your comment after the session ends. I'll definitely respond to all those individual queries which you have. Okay, that kind of counseling we are planning very soon. In fact, do one thing, there is a YouTube short that I have uploaded just some time back. Comment your rank, everything on that video. Based on that, we'll conduct a counseling. Okay, so here is the logic. The capacitive reactance is 1 by omega C. Now, according to the question, this capacitance increases 2 times, double. Omega also increases 2 times. So, denominator, do you see guys, denominator has increased how many times? 4 times, but it is in the denominator. So, basically, XC has increased 1 by 4 times, option C guys. Excellent, excellent, very good, very good. Many of you got it. Some of you made a small silly mistake and they said 4 times. Remember, it is in the denominator, not in the numerator. If it was numerator, then it would be 4 times. Let's see the next question coming up on your screen, and here it is. For a capacitor and inductor connected to AC, for a capacitor and an inductor connected to AC, who has low resistance to AC and who has high resistance to AC, or both of them have the same one? Come on. Oh, no problem. Join in. I hope you are fine, Hindutva. All right, Dayani, no problem. Bacha, come on. Let's see if you can do this question. For a capacitor and inductor connected in series, who has more resistance and less resistance, or both of them have low or both of them have high? Think about the formula, you will get the answer, guys. It's very easy. Think about it. XC is 1 by omega C. XL is omega L. Now, when you talk about AC, what is the meaning of AC? AC means frequency will be there, omega will be there. So, it has some angular frequency. So, the one which has more AC, that means the frequency is high because the variations are high. If it's a good AC, that means the variations are very high, rapid. Then XL will also increase. But here, if omega increases, then you can clearly see XC decreases. Hence, you have found your answer. A capacitor has low resistance to AC, whereas an inductor has high resistance towards the AC. Because when the frequency increases, XL increases. When frequency increases, XC decreases. So hence, option A should be correct. Very good. Most of you got it finally. So hence, option A, guys. Yep, that is the correct one. Moving on to the next question coming up on your screen now. An AC voltage of some value, which is a function of time, it is connected across a circuit which contains some AC ammeter and a capacitor of capacitance. So what is the reading shown by the ammeter? Those of you are not able to visualize, here it is. This is my AC source, this is my AC ammeter. Okay, this is my AC ammeter and this is my capacitance. So the question is, what is the reading shown by that ammeter? Let's see how many of you can do this question. Very straightforward. Come on, come on, come on, my warriors. Yes, in DC it is opposite. Correct, Dark Knight. Perfecto. Let's see if you can do this question. Okay, so EMF is given and the question is find the current. Well, how do I do that? Look at this. E naught amplitude is 200 root 2. So that means the one which is outside, 200 root 2 volts. Do I know XC? Yes, I think so, because it is 1 by omega C. What is omega? Omega is this value. Okay, this value 100 is nothing but omega. This value was E naught. Okay, this was E naught. So omega is nothing but 100 and C, capacitance, that's 10 to the power minus 6. Correct. So now what do I do next? This will become 10 to the power minus 4. So it will become 10 to the power 4 and that is ohms. So that is XC. But we all know this. EMF, voltage, is current into resistance. So therefore 200 root 2 is I naught into 10 to the power 4. Everybody fine till this point? So therefore I naught will be 2 zeros goes, so 2 root 2, and you will have divided by 100. Interesting, which is nothing but 1 by 50 and into root 2. Now comes the catch. Now comes the catch, guys. Be careful. You need to find out the reading shown by the ammeter. Remember, I have told you this in the last class. Ammeter always measures RMS. A AC ammeter always measures RMS. So this is I naught. So what will be RMS? RMS will be I naught by root 2. Root means square. So that means it will be just 1 by 50 amperes. 1 by 50 amperes is nothing but 20 milliamperes. Yes. So be careful. This is nothing but 20 into 10 to the power minus 3 amperes. Yes, that's it. I hope you guys now understood this. Lord Zarko, there are nurture series lectures. Lord Zarko, just watch the nurture series. This is one of the last few topics of 12th standard, so I doubt if you will get it. Okay? Yeah. Chalo. So that's the catch. Many people make that mistake and they wonder why that root 2 came. Alrighty. Let's get moving to the next one. But before that, let me also tell you, if you guys have any kind of doubt, you're solving some book and you don't know where to go, and most of you, I know, they go to Google, search for the answer, and they just, okay, fine, I understood. But that's a wrong method, because many websites give wrong answers and wrong methods. Final answer is correct, but methods are wrong. And sometimes you don't know whether your method is correct or wrong. And you don't have anybody to ask or verify, because you and your friend both are in the same situation. So guys, you can make use of the Vedantu doubt app. You can ask unlimited free doubts from morning till night, and you can send your solutions. You can ask for hints, whatever, with our doubt experts. They are subject matter experts. So that's the doubt app facility which you should use. Now let's figure this out. If all three are together, then what will happen? This will be very interesting. Okay? If all three are together, then what will happen? This is very interesting. Look at this. Voltage across inductor, voltage across capacitor, voltage across resistor. It has all been connected across this final voltage. Tell me one thing. Across all these three components, what will be same? Will their voltages be same, or will the current passing through all of them be same? Think about it. What do you think will be same? Will the voltage across all of them be same? All these components, or will the current passing through all of them will be same? Think about it, my warriors, and let me know in the chat box. Come on. Think. It will be the current. Exactly. It will be the current, because whatever charge flows through inductor, same charge flows through capacitor, same charge flows through resistor, same charge flows through the AC source as well. So in series LCR, what will happen? The current is same. Voltage, okay, the potential drop may be same, okay, may or may not be the same. But there is one very interesting thing which will happen. If I ask you, or rather if I tell you, VT is the instantaneous voltage across the total circuit, or basically it's the voltage of the source. Okay, it is the voltage of the source. VL as a function of time, VC as a function of time, and VR as a function of time. Okay, these are all the voltages across the inductor, capacitor, and resistor. Think the voltage drop at some instant, let's say it is 2 volts, at some instant, let's say it is 3 volts, at some instant, let's say it is 4 volt. Example. So the total voltage drop will be 2 plus 3, 5, 5 plus 4, 9. So can I say the total voltage drop will be voltage drop across the inductor plus voltage drop across the capacitor plus voltage drop across the resistor? As simple as that. Everybody agrees to this statement? Everybody agrees to this statement? Hello Mannat, don't worry bacha. I'm still here, Mannat Kumari, and one more thing, my lecture series are starting on Vedantu Pro next week onwards. On the Pro, there is a micro course. Please watch the video which I just conducted in the afternoon on this channel and register in my course. I'll be mentoring you over there. Don't worry, I'm not going anywhere. Okay, I'm always there for you. Don't be sad. Acha. So the total voltage will be the sum of each of these voltage at any instant. This is at any instant. Very, very interesting. But think about it. Think about it. If I ask you VL0, VC0 and VR0, what are they? They are nothing but the amplitudes. They are nothing but the amplitudes. Will I be able to add all of them and get the total voltage amplitude across the entire circuit? That's the tricky question. And the answer to this is no. Yes, this is not equal. You're like, what the hell? Instantaneous values add, but the final amplitudes don't add. There is a reason for that. Why won't it add? Because the voltages don't reach maximum value simultaneously. Remember, the voltage lags, or it is ahead, or it is in phase for different components. For different components, it can be ahead, it can be behind, or it is probably in phase with the current. So when voltage is maximum across inductor, maybe it is negative maximum across the capacitor, maybe it is zero across the resistor. So things can change. That's why they will not add amplitude wise. That's something which you should understand. The time instants will add, but the amplitudes won't add. And there is a beautiful graph to show all of this. Okay, so Manisha Rani, how about posting your query in the comment section? I'll definitely respond. There is a YouTube short video which I just created. Post all your queries there, because we are going to conduct counseling based on your comments on that short video. Okay, just do that. Look at this. This is a beautiful, beautiful, diagram. I love this. This is the current diagram, how the current varies. Look at this. The current varies like this. Let's say a sine function. For example, this is a sine function, for example. Okay. Now, if the current is a sine function, observe this, the voltage in the resistor is also a sine function. We all know this. For example, if over here I draw the current phasor, whose phasor it is? This is nothing but the current phasor. We all know that the voltage across the resistor is also in the same phase. Interesting. So this is the voltage across the resistor. It's in the same phase. Great. But inductor, nah. Look at this. This is a cosine function. Look at the graph. There is a phase difference between the voltage and the current passing through it. So when the resistance has this kind of voltage, the inductor has a cosine voltage varying to it. You can see when voltage across the resistor is 0, that time inductor has maximum voltage. Capacitance, on the other hand, has negative maximum voltage. Everything is varying in different phases. You can see that. Hence, what will happen is that the voltage across the inductor, it is ahead. Remember, inductor's voltage is always ahead of the current. Voltage leads the current in case of inductor. So the phasor will look like this. I hope that makes sense. And lastly, for the capacitor, it will be below. So it is behind, the current leads the voltage. So VC will be like this. Now, let me give you a simple wave problem. Forget AC circuits for a moment. Just forget it. Just go back in time and recollect your waves. These are three waves. This is wave 1, this is wave 2, this is wave 3. They are not in phase. They have amplitudes, something like VR, VL and VC. If these are the amplitudes and you want to combine these waves, how exactly do you superimpose these waves? How exactly are you going to superimpose these waves? Do you remember it? Yes, you need to use vector addition of their amplitudes. You use the phasor method. That's why we learned phasors. So all you need to do is treat them like vectors to add them. So the total voltage is actually the vector sum. The total voltage, let's say I call it V0. Okay, I'll just put it as VL0, VR0 and VC0. Okay, so V0 will be nothing but it will be VL0 vector plus VC naught vector plus VR naught vector. Vector addition of these green vectors that you see over here. Do you guys get it? Remember, whenever you have waves and you have to add them, take the vector addition of the phasors of those waves. That's all you need to do, nothing else. Now things will be simple. Achha, how do I add them? Well, I think I'll get rid of VL0 and VC0 first because they are directly opposite to each other. So how about subtracting VC0 and VL0 magnitude wise? So you will be just left with this much. Okay, so this will be VL0 minus VC0. Okay, this much. This minus this, when you add them, they will partially cancel. So you'll be just left with that. Now you have that VR0 over here. So adding both of them, what will you get? You will get a vector like this, and this is your V0 vector. Okay, the final voltage amplitude of the source. As simple as that. This is nothing but voltage of the source is V0, okay, something, sine or cosine, whatever. Okay, so it will be something like that. Okay, so this is what you will get. So remember, I had just told you V0 is not VL0 plus VC0 plus VR0 in the previous slide. So what is V0 equal to? V0 bar is equal to VL0 bar plus VC0 bar plus VR0 bar. Vector addition. But magnitude wise, is there a way? Yes, look at this, Pythagoras theorem. Use Pythagoras theorem and you will get it. So it is root of base square, which is VR0 square, plus this square, which is VL0 minus VC0 whole square. This is what it is. So this is the formula for voltage. I hope now it makes sense. Excellent. So this is how it works. In AC circuits, it's all about vector addition. Those of you who understand AC circuits via vector addition, that's it. It becomes very, very easy to understand. Now comes the best part. Okay, so I got all of this. So I also saw that the final voltage will be here. It will be the vector addition of all of them. Okay, this is what it is. Okay, this angle phi, okay, this angle phi is the phase difference between the final voltage or the total voltage and the current. So this is your phase difference. Can you see that? So tan of phi, geometrically speaking, what will be tan of phi? Tan phi is also here, by the way. Tan phi will be opposite. What is opposite? Opposite is VL0 minus VC0 divided by base. What is the base? It is VR0. So what is that phi? Phi is nothing but phase difference. It's nothing but the phase difference. That's all you need to know. Great. Now, last thing that I want you to understand. Okay, we have drawn voltage phasors. We have seen the total voltage is the vector addition of individual voltages, not just the scalar sum. There is one last triangle or phasor diagram which you should understand. A lot of people do not know this or forget or probably do not use this while solving problems. Well, this is my current. Okay, this is my current. I can also draw a phasor diagram for, guess what, the resistances. Yes, you heard it right. Resistance voltage is in phase. So draw the resistance also in the direction as of the voltage. VR0 is in phase with current. Resistance is also in phase. But inductor is on the top. It leads the current. VL is on the top. So XL, remember, equivalent of resistance. What is it? XL is on the top. Capacitor is below. So draw the capacitor also below. This is XC. That's it. This is 90 degree. Now, here is the last thing. If I add all of them vectorially, let's see what do we get. Acha, first let me get rid of these two. So I will just have this much left, XL and XC. If I subtract them, okay, so I'll get XL minus XC on the top, and here you will have R. When I add all of them together, I get something new. Yes, I get something new over here. This is neither reactance, this is neither resistance. It's a combination of both. Resistance and reactance combined together. That is called Z, which is nothing but impedance. What is it called? Impedance. This will be again the same angle phi which you are looking over here. Okay, that's the same angle. So what is Z technically speaking? Z vector is XL vector plus XC vector plus R vector. But magnitude wise, it is nothing but root of, use Pythagoras, base square plus height square. Same thing like this. It is R square plus XL minus XC whole square. Now tell me one thing. Are you going to remember this formula, this formula, this formula, this formula, or even this formula? No, you're not going to remember anything. No, you're not going to remember anything. The thing is, you're just going to remember this triangles, these phasors. That's it. If you remember this and you remember this, entire thing is done. That's it. You just need to remember via vectors. You should know who is where and what addition gives you what. So addition of all the voltages gives you total voltage. Addition of resistances and reactances gives you impedance. That's it. So Z is a combination of reactance and resistance. That's it. Reactance plus resistance gives you impedance. It is the total resistance of the circuit. It's the total resistance of the circuit. That's all. As simple as that. Also, from here, you can see tan phi is opposite by base. What is opposite? XL by XC, XL minus XC. So this is also XL minus XC divided by base. What is the base? R. So tan phi can also be written down like this. If you notice clearly, these vectors are directly proportional to reactances. Don't believe me? I'll tell you how. Look at this. Okay, observe this. Okay, maybe I can use this space over here and I'll write it over here. VL naught, VR naught, VC naught. Okay, what is VL naught, VR naught, VC naught equal to? First I'll put current. I. And look over here. VL naught is I into XL. VR naught is equal to I into R. VC naught is equal to I into XC. That's it. So they are all proportional. VL is proportional to X, VR is proportional to R, VC is proportional to XC. So that's why when you take this triangle, these phasors or these vectors and these vectors, they are all proportional to each other. So that's why the angles are also same. You can see that. Did you see that? The angles are also same. So if you take this vector, let's say XL multiplied by I, you get VL naught. If you take this vector multiplied by I, you get VR naught vector. If you take XC vector multiplied by I, you get VC naught vector. As simple as that. Okay, very, very interesting. And lastly, I would also add over here one last thing, and that is V naught, which is the total voltage. The total voltage is that total current, but what symbol do you think I should put over here? Come on, think about it. What is the symbol that I should put over here? The total voltage across all of them, total voltage will be that current into what symbol should come? Think. Obviously the total resistance, which is called impedance. So over here you will get Z. That's how it is. So now it becomes very easy for you to remember all of this. That's all that is there in AC circuits. Yes, there is power loss and all of that, which will be coming next time. But this is the theory of AC circuits. Now, are you guys now ready for some questions coming up on your screen? Okay. By the way, you should probably take a screenshot of this. Yeah, you should probably take a screenshot of this very important slide, which is there on your screen. Okay. Now, all of this is also going to be there in your PDF. You can download it later on. Now, let's do this first question coming up on your screen. Come on, my warriors. A 50 Hz AC source of 20 volts is connected across R and C. Okay, as shown in the figure. The voltage across R and C is as shown in the figure. I think this was repeated statement. Just ignore that. The voltage across R is 12 volts. So I think this is repeated. Just ignore that. Voltage across R is 12 volts. What is the voltage across C? Let's see whether you can solve this question. Very, very interesting, simple question. Starting with easy, then we'll go to some good level questions. Come on, my warriors, figure this out. The voltage across the resistor is given to be 12 volts and voltage across capacitance is asked, and this voltage is 20 volts. Many of you are going to give a wrong answer. Happy Engineers Day, Kirutia. Yes, thank you. Okay, so the answer is not 8 because these values are all RMS values. Be careful about it. So use vector addition, guys. So recollect how it was. Voltage across resistor used to be like this. Voltage across capacitor used to be like this. And the total voltage will be here. This is the total voltage. This is given to be 20. And this is given to be how much? 12. So the question is, how much is VC? Obviously, we all know VC square plus VR square is V square. So VC will be root of V square, which is 20 square minus 12 square. So what is it? Yes, it is going to be 16. 12, 16, 20 is Pythagorean triplet. You should know that. It's a Pythagorean triplet, nothing else. So hence the answer is 16 volts and it is not 8 volts. A lot of people make that mistake. So that's the answer, 16 volts. Let's get moving to the next question coming up on your screen. Okay. Happy Engineers Day to you too, Raji Pratap Jadhav. Next question. When an inductor, a capacitor and a resistor are connected in series across a source of alternating EMF, the potential across the inductor, capacitor and resistor are 70, 30 and 30. Find the EMF of the source. What is the EMF of the source? Manoj edits, yes bacha, you can definitely cope up, but you need extra efforts, extra hard work. Sit in the night, cover up your backlogs and try to attend the live classes every day. Do not miss, no matter what, the live classes. Even if you don't understand too much, it's okay, but always make sure you are live in the classes, whether it is in coaching or whether it is on YouTube. Okay, so you can cover it up, set a target of February. By February, you will be able to complete almost most of the syllabus. Okay, I have made a special lecture on how to cover backlogs just some time back. Okay, so how do you do this question? First of all, the potential drop across the inductor is 70. Inductor is always on the top, remember, VL. So this is 70. Then you have capacitor. What is the capacitor's voltage? Capacitor's voltage is 30. Okay, it is here. And resistor, that is also 30. Achha. So add all of them. First I'll get rid of inductor and capacitor. So 70 minus 30 is how much? It's like adding vectors. This is 40. And how much is left? 30 is left. So how do I add them? Pythagoras. So this will be root 40 square plus 30 square. 435 standard triangle. So this will be 50 volts. That's it. Is 50 there in the answer? Option A. Correct. Very good. Many of you got it now. Excellent. Excellent. Let's get moving to the next question. Option A is correct. Let's see how many of you can get this. Very good, Nikhil. You understood it. All right, Manoj. Very good, Theresa. Very good, Sai Prasanna. Excellent. Danny, I hope you understood your mistake. All right. A bulb and a condenser are connected in series for a AC source. When you increase the frequency of the source, the brightness will. Interesting. So a bulb is nothing but a resistor. So this is nothing but a bulb. Okay. And a condenser means capacitor. So this is nothing but a condenser or a capacitor. Okay. They are connected to a AC source. This is your AC source. Okay. So what will happen to the brightness if you increase the frequency of the source? Very interesting question. Now, remember the brightness, okay, the brightness of the bulb completely depends on the power loss in that bulb, power loss in the bulb. So, if more heat is generated, more power is lost, more the brighter the bulb will be. So, the brightness completely depends on the power loss. And what is power loss dependent on? Power loss is I squared R. Do you remember? I squared R. So, if the brightness has to change, the current has to change. And what will the current depend on? Acha, the current is voltage divided by Z. voltage divided by Z. V is IZ, remember that? Z is impedance, total impedance of the circuit. Why impedance? Because resistance is also there, capacitance is also there. When two things of different types are there, it becomes impedance, not reactance or resistance. Okay, great. And what does impedance depend on? Obviously, impedance depends on resistance as well as capacitive reactance. What does capacitive reactance depend on? Acha, it depends on angular frequency. Resistance depends on resistivity, length and area, but that is none of the concern over here. Frequency changes. Okay, let's see now what will happen. If frequency increases, what will happen to XC? XC will decrease. Now, the frequency of the source is increase, yes. So XC will decrease. So Z will also decrease. Reactance has decreased, Z will decrease. If Z decreases, denominator decreases, so current will increase. If current increases, the power loss will also increase, and the brightness will also increase. Hence, the answer should be option A. What a beautiful question, guys. Yep, that's the answer. Okay, so that's how you need to form a logic. Do you see? This is how I think. A lot of people ask, sir, how do you think? I think step by step. You need this, acha, so that means I need this. If I need this, okay, that means I need this. So when you think in steps logically, nobody can give you this step directly. If you get this step, then yeah, something is wrong. Okay, so option A is correct. Yes. Will you please suggest a good channel for NEET physics? Well, Usha, you can watch it over here itself. Okay, the physics for JEE NEET is similar, bacha. Okay, because the only thing that changes is the difficulty pattern of paper. That's it. And I'll often come on VBAR Tonic to help all the NEET aspirants as well. But otherwise, it's 7. You can see that. Okay. So, unfortunately, Rajay Pratap, you can ask academic doubts on our doubt app. So, doubt app is there on Vedantu. You ask all your academic doubts, they'll get cleared. But if you have some strategy problems, some personal problems, you can definitely write it in the comment section. But if you think it's too personal, then post it to me on Instagram. I will definitely look into it. Okay, chalo. Next, there is a series circuit, R, L and C. All are given. Omega is also given. What's the impedance of this circuit? This is so, yes, omega is angular frequency, correct. Angular frequency, correct. All right, come on my warriors. Let's see how many of you can do this. Come on, figure this out. Achha. Let's see how are you going to do this. Come on, I'll give you some time. Think about it. Omega is angular frequency, correct? If frequency increases, omega also increases, bacha. Somebody was asking, I think Shalini, if frequency, omega is 2 pi f. So if f increases, omega also increases. All right, so I think omega is given. I think we can find out all these things. Impedance is asked. What is impedance? Impedance is the sum of all the terms like resistance, XL and XC vectorially. So magnitude wise, it is nothing but, I just need to take Pythagoras and all of that. So let's find out all these things. I think I will need all of these things to find out the impedance. So what is XL? Achha, XL is omega L. Okay, if it is omega L, what is omega? Omega is 10 to the power 3. Inductance is 0.9, which is 900 ohms. Similarly, what is XC, guys? XC is 1 by omega C. Omega is 10 to the power 3. Capacitance, where is capacitance? It's 2 micro, 10 to the power minus 6. So this will become 10 to the power 3 divided by 2, which is 500 ohm, correct? All right. Resistance is already given. Okay, resistance is already given. Now, in this triangle, draw all these values, write all these values. So, XL is 900, R is 300 and XC is 500. Simplify this triangle. Okay, don't remember any formula. What I have been telling you, for AC, just look at it like vectors, phasors. Don't remember formulas so much. Acha, so these two will cancel. 900 and 500, I'll be left with 400, and horizontally it will be 300. Oh, I have to add both of them. The addition of both of them Okay, vectorially will give me z. How much will z be? Use Pythagoras. That's it. It's 400 square plus 300 square. We all know 435 is a Pythagorean triplet. So instead of 5, it will be 500. So that's it. 500 ohm is the answer, which is option C, bacha log. Is it clear? Raji Pratap, you can definitely leave some comment, on the, what do you say? Comment section. Or probably if you have a very personal doubt, create an Instagram account, bacha. It's not so difficult, okay? You can create it. So that's the answer, guys. Option C. Amazing, amazing. Let's get moving to the next question. Oh my God, naughty boys. Hello, naughty boy. Okay, hi Vikram. Thank you for all the fire. Swarlina also understood. Let's get moving. Yes, Teresa. Yes, Dayani. Let's move on. In a series LCR circuit, 10 ohm, impedance 20 ohm. When there is what is the phase difference between the current and the voltage? Beautiful question. Resistances and impedances are given. Current and voltage, what's the phase difference? Think about it. Well, just some time back, I had shown this triangle and these phasors. This is current and this is the final voltage. We had seen this is the phase difference between them. And it so happens that if you draw this as R and you have your XL and XC, you do the vector addition and finally you get Z in this direction. This also is phi. I hope you remember this. If you remember this, now your job is sorted. Think, what is cos phi? Like, sir, you didn't give me formulas for cos phi. You gave me formula for tan phi. Guys, what did I tell you? Remember, AC chapter is all about phasors and vector addition. It's not about formulas. Many people learn it and teach it the wrong way. So cos phi, it's adjacent side by hypotenuse, which is Z. You see over here is a nice right angle triangle. What is R? Do I know it? Yes, it is 10. What is Z? I think I know that's 20. So it's half. Naturally, phi. Whose cos is half? It is 60 degrees. So is 60 degrees there? Yes, it is. 60 degrees is the answer. Okay. Very good. Very good. Excellent. Excellent, guys. So that's how it is to be done. What a beautiful way to solve the questions. And that's how simple AC is. Okay. So guys, if you want to get into my batch, you want my mentorship, my personal attention, then please join the Vedantu subscription. Plus, when you join it for 1 year, you get Vedantu improvement promise. That means you are going to get full attention, and if you do not improve, then all your money is returned back. That's crazy. So there are 2 homework questions for you guys for tonight. So solve this and post all the answers in the comment section below. So this is your first homework question and this is your second homework question. Okay, so please post it, guys. So this is how you post it. Like if you check out our last video out here, where is it? Okay, so let me go to videos and oh yes, where was it? Alternating current. Yes, lecture 1. This is lecture 1. Oops, I'm not looking for a house online. Thank you very much. Okay, so this is how you post it. Homework answer. Very good, Nareen Harsha Venkateshwaran. He has posted the answer immediately after the class. So this is how you post it. Okay. Another thing that I want you to see is this particular video in our past videos. This one, the Enthuse biggest gift. So check this video out because I have told all the courses which I am conducting. Okay, so I think this video will play now. I can probably skip this ad later on, or maybe I can just show it to you. So in this video, I have explained all my micro courses which are available. Okay, and this course which is starting, okay, this courses which are starting this Monday, September 20th, my courses are starting on the Vedantu Pro subscription, so do not miss that. That's another thing which you should know about. Also remember, guys, if you're watching this video right now, the way you can join my course is go down and check this out. If you're class 12 student, click this. Dropper student, click this. Either of them. Okay, just click this. Go below. There are 3 versions and you can see all the details have been mentioned. You choose plus version if you want the personal mentorship. You choose classic version. If you want doubt solving, and if you want everything else apart from these two, then you go for the light version. The course price for the entire year is 36,000, but you have an option to pay monthly fees, EMI, or you can even buy it for 1 month. You can try it for 1 month, or you can buy the complete course and you can use EMI, monthly payment option also. It's up to you. Just make sure you use the coupon code SHHPRO so that you get the 10% off. Alright, so that's what it is. I'm hoping that you're going to post all the answers to the homework question below after the session ends. Alright, thank you guys very much. Bye bye Vikram, bye bye Rajiv Pratap, bye bye Nikhil, bye bye Shalini, bye bye Swarlina, bye bye everyone, bye bye. Take care Sai Prasanna, bye bye Teresa. This was Shreyas here, and I'll be coming live again on, after 2 days for the third class of AC, so do not miss that. Take care, stay fit, stay healthy. This was Shreyas here. Hasta la vista.